Hello everybody, my name is Arash. This is LEC 204 Digital Design. As the course name suggests, this course is all about digital design. I guess you all are second year students. You have had electric circuits, right? Not electric circuits? Okay. You haven't had electronics. So in some courses you learn about analog design. In this course you will be learning about digital design. In digital systems, which are prevalent today, every signal can either be 1 or 0. We are trying to describe our systems using ones and zeros. In this course, we will be exploring the fundamentals of digital design. So you will go into the most basic level in which you can design a system. How many of you have ever worked with microcontrollers? How many of you have ever worked with computers? All of you, right? At the core of a computer, there's a processor. A processor consists of a lot of digital circuits. If you break down that processor, you eventually reach down to the most basic component of digital systems. I mean gates. In this course, we will be implementing our designs using gates, the most basic ones. In electronics, in analog electronics, we have resistors, we have diodes, we have capacitors and stuff. In this course, the most basic element that we will be talking about are gates. Okay, each of you, hopefully, I think there are 75 people in this class, not right now, in this class, this semester, and we have 75 of these. Okay, so when each of you will receive one of these, along with a license agreement, that if you lose one of them or break it, they will take $100 from you. So please be careful about these guys, because up to now we have always had excess amount of these. Okay, for this semester there's just as the number of students, and as you see here, can you see that Koç University thing? We designed this. One of the students of Koç University, Altinbek Izabekov, he designed this, and that's specific to us. Okay, let me explain more about our board. This board is a development board. There is a core to this board. You all see that square, this square component here, right? This is called the FPGA, Field Programmable Gate Array. This is the heart of this device. The other components are just peripheral to this device. For example, we have a USB connection. You connect your computer via USB to this and put your program in it. So some of these guys at the left of the board, these are all related to the USB connection. This is the on-off switch. These 10 switches here, 6 buttons here, 10 LEDs here, and a 7 segment here, and some pins here are inputs and outputs of the device. So which of them are inputs, which of them are outputs? What are keys? Are they inputs? Inputs, right? What are LEDs? Outputs, right? What is the 7th segment? Output. The buttons? Input, pins. Input or output? You can change them. You can use them as output or inputs. So this is the basic of our device. We will be working with this device and a program named Xilinx ISE, which will eventually make you pull out your hairs. It has made people crazy. I mean, it's not a bad program. It's just that writing program for hardware is a lot more different than writing a software. You all have had experiences with Java, right? Or any other program, Visual Basic, C++, some kind of those software developing languages. Here we will be dealing with a hardware description language named VHDL. Okay, so this is our board. I will show you a program on it, but let's see. So this is a field. Oh, I didn't explain about this core component. This is the heart of the device. This is from Xilinx Corporation. There are 2 corporations making FPGAs. The most prominent one is Xilinx. The other one, I don't remember its name. So if you look at it, you will see the family name, Spartan, and you will see some specifications that are important when you work with this device. So FPGA stands for Field Programmable Gate Array. Any idea what is this? Anyone has an idea? What does this mean? Okay, as I said, the most basic component of digital systems are gates. Who knows what a gate is? Yeah?
It's a logic gate. Depending on the signal it receives, it'll either allow the signal to continue or cut it. Or invert it. That's also a possibility.
Yeah, exactly. Gates are multi-input devices that, depending on the inputs, they give you an output. For example, an AND gate has 2 inputs. Okay, we are saying AND. It says, okay, my output is 1 if input 1 and input 2 are the same, are 1, right? If one of them is 0, and one of them is 1, what happens? What's the output? 0, right? So we have some basic gates. Before FPGAs, if you wanted to design a digital system that consisted of, for example, 100 gates, you should have soldered the gates you wanted. So you wanted an AND here, and OR there, and another AND. You needed to connect the wires. After FPGAs, you don't, and it's a pretty revolutionary invention. It changed many things, FPGA. After FPGAs, you don't solder those. You don't connect those wires in the real world. I mean, you will be doing those, but not by soldering. You will do it programmatically. So you will have a lot of gates. You will be changing the wiring between these guys by your program, and you can rewire them. So it is a pretty fascinating thing. I mean, think about it. They give you a computer, okay? You can do a lot of stuff on your computer, but one thing you cannot do: changing the structure of your CPU. Okay, changing the structure of your computer. You have just been given a device that works, but you have no control over the wiring. But in FPGA, you can change the wiring with your program. With your software, you change a physical thing. So that's pretty important. For example, there are, for example, in a missile, okay, in a missile, you cannot use the computer. Why?
It's too general.
It's too general, and too general leads to
Expensive.
no.
Complex.
Actually, these are pretty expensive. This costs like a computer, like $100 or more. If anything is more general, multi-purpose, it's slower. In missile, you need to be pretty fast. So you cannot use a computer. In a stock market, in a stock market trading, if you know about stock market trading or automated trading, those guys are counting on microsecond. If you can place an order in the stock market, a microsecond sooner than the other guy, you will win. They call it micro trading. Yeah. So these have pretty specific uses, and it's not something that you learn, and it's something that if you learn it and go to digital design, you will pretty much use it, and it will be a valuable skill to have. Yeah.
Is it like changing the architecture to CPU?
Yeah. You can design a CPU by this. Not by this is small, but with bigger ones, you can design a CPU yourself. So that's pretty amazing, right? If before FPGAs, if you wanted to design a CPU, you would have had to spend millions of dollars to be able to have a CPU of your own structure. Okay, right now you can see if it works. That's the building blocks for the CPUs, any digital device that you want to. Did I answer your question? Okay, let's cut the speaking and go to the business. So, first of all, I want to show you a program that I wrote. So this semester it will be really easier for you. In the former semester, we have decided to change things. In the former semesters, actually I need to speak with your instructor first, but I intend to give you some codes so you can work around those codes and make them better and have a foundation for your programming. So it's not decided yet, but I will ask your instructor. So this, come on, what happened? Oh, let me duplicate it. It is duplicated. Okay, we write our program, we compile our program. I'm coming from the end to the beginning. After you wrote your program in Xilinx, you need to download it to your FPGA. So you will be given this to a USB connection. You connect your USB into your computer. There will be another program named Prometheus. You will use Prometheus to download your program into FPGA. So there is for example, there's a program. There will be some Yeah, I don't know if you can see it. So there's a program that slides the LEDs. Do you see it? You all see it? So there is a file with the extension of bits. This is a file a compiled file. So that's the wiring file. We upload it to this and it does what we want. For example, button to LED. It's another one. What does it do? Okay, I ask you to be quiet, not this quiet. Huh?
It turns on which button we.
Yeah, yeah. The button, you can turn on the LED by pressing the button. Okay. So this, I mean, the programs we will write are a lot more sophisticated than these. You know that saying, they teach you 2 + 2 in the classroom, and then in the exam you will see an indefinite integral or so. So it's like that. Okay. So the labs that you will be doing are pretty hard. So if you are counting to do the labs in the lab sessions, please don't count, because you won't be able to do that. So please install Xilinx ISE on your laptops. It won't install on Mac. So if you have a Mac, you need to install Windows on it. Okay. Everybody has a Mac here? Yeah.
Are you sure it doesn't work with wine?
What?
Are you sure it doesn't work with wine?
It doesn't work with Mac.
I mean, it's worth a try.
I mean, it's the third time I'm doing this, so I'm pretty sure. But I mean, there is always a chance for everybody to be wrong. You can search for it. I personally don't own a Mac and didn't try to install it on a Mac, but yeah.
You can download emulators.
Yeah, you can download emulators. For example, a Linux emulator. Okay, for the rest of you who have a Windows, okay, and probably Windows 8 or 10, there is a fundamental problem with ISC. Please, Engin Hoca will give you 2 files that I prepared for installing ISE. Okay, please go over it point by point. At one point it says do not install the Windows 10 version, and every semester there are 2 or 3 guys coming to me, okay, we installed the Windows 10 version, it doesn't work. And it clearly says do not install the Windows 10 version. You need to install a former version of it and work around it with a patch that I prepared the patch. Just go through those 2 files and you will be okay. Yeah. You hate me? Not too much?
Not yet.
Not yet. Yeah, you will. You will. I hate myself in this course, so. What? Linux version. I mean, for the Linux version, you need to have a virtual machine, and that slows down your computer. I mean, this program, as is, without the Linux version, has its own problems. Okay? You can do it. I mean, what Xilinx did was giving you a virtual machine for Linux and giving you, I mean, their patch for Windows 10 version is that they give you a virtual machine and say, okay, use Linux instead. And I personally do not like that. Okay. So let's go from scratch, make a new project. make a program, a small program, see how it works on this, and then we are done. And I will yeah, it's still recording, fortunately. So I will render the file. I will give it to you, and you can go over it later too, because I know that learning a programming language or a software without having that and practicing on the computer is not that easy. So hopefully nothing goes wrong. I can give you the recording. Okay, we go to File, Make New Project. We need to pick a we need to pick a name for our project. The name cannot have space in it, or I figure it cannot have some characters, and just make a sensible name. Okay. Do not be so creative with the name. Just okay. Here, top level source type, we use VHDL hardware description language. And a disclaimer, I'm not in any ways an expert on Xilinx. Being an expert on this program and FPGAs takes you a lot of time. So I just know enough to get through this course. So yeah, there will be nobody is an expert on VHDL here. If you be an expert on this, quit, go to a firm, one of those firms that I told you, and get big bucks. Okay, so don't be a TA for this course. Okay, so here, this is very important. The project, new project wizard, the project specifications. We need to pick the right amount, the right selections for our program. It doesn't work. Otherwise it doesn't work. So the family of our device needs to be a Spartan 3A and Spartan 3AN. And the device itself is XC3S50A. It's written on this, but when you receive that, you will realize that it's not readable. But it's on it. So the packaging is important too, and the speed. These are very important. Preferred language, there are two languages that you can describe the hardware in, VHDL and Verilog. We will be using VHDL. Some say Verilog is easier, some say, but they are not much difference. There won't be much programming. There won't be much programming in this course. It's mostly just some lines of code. Okay. So, yeah. So, we made our project. Okay, and here you see the device name and packaging. So, our project is empty now. We need to add a source to it, a module to it. Okay, there are some number of modules that you can use. Here we use VHDL module. So you will just use VHDL module. Sometimes if you are doing simulations, VHDL test bench. Okay, none of the other ones you will use. So let's call it I call it main. Okay, here it's asking us to decide about inputs and outputs. Okay, so you can do it later. We can just hit cancel, not hit cancel, hit next, and then do it later in the code. And we can do it here. So I want to have an easy program. I want one of these LEDs to lit when I turn one of the switches on, and the other one to lit when I push one of the buttons, right? So how many inputs should I have? 7, 1, 2 inputs, 2 outputs, right? Because there are 2 separate LEDs, one for the button, one for the key switch, right? So it will be 2 inputs and 2 outputs. Okay. Inputs and outputs are named, we call them ports. Easy, right? So let's key. It's an input. There are 3 types of port that you can have. An input that you can just read, an output that you can just put something in, and in-out that you can read and write at the same time. Normally we don't use in-outs. I mean, I haven't had a situation that I used an in-out. Key, button, okay, LED, key, come on, LED, button. Okay, should I hit next? Am I wrong in some way? What? Exactly, which one? LEDs should be outputs, right? Okay. Output. So, and these are, if your input has, for example, maybe you want to have all of these keys as inputs. The wiser choice, I mean, you could have 10 ports, but the wiser choice would have been to have a port that has 10 components. We call that kind of a port a bus. So if I tick this, it will be a bus. What does MSB stand for? Most significant bit. What is the highest number of bit? Highest bit. And LSB, least significant bit. You just say, okay, my last LSB is always 0, so that's 0. And for example, it can be 5. Okay, so it will be 5, 4, 3, 2, 1, 0. It will be 6 ports in it. You will use it. You will. It's not hard. Okay, so as far as I am concerned with my ports, I am okay. So I hit next. So we can check here again. Port definitions, key, bot, LED key, LED bot, pins, they are pins, in and out. Finish. Okay, it makes the structure of the file for us. So these green guys are comments. I figure that you somehow are familiar with comments. You can write your names here, the date, anything that nobody ever touches, but it's the library. Okay, so Xilinx VHDL is a you have used libraries in Java, right? You have used libraries. Here too we have libraries. So here we are using IEEE STD logic, standard logic. You can, when you progress, you will see that you will need some functionalities out of the box. For example, you may need to interpret a binary sequence as a number. Then you will use numeric libraries. So here every module is an entity. So when we say entity, we mean a VHDL module. So we are saying entity main is, here we are describing our outermost appearance of our module. Okay, so we are saying entity main is port. We are defining our ports. Key is input, standard logic. Bot is input, standard logic. LED key is output, standard logic. Here we are saying this is when someone looks at our module, they see this. At the architecture part, we will be defining the signals that we will use, or any straight wiring. Okay, so I want to wire one of these keys to one of these LEDs. Okay, so I say oh, sorry. I shouldn't define it here. Okay. So, can I compile my program now? Will it work? Yes? Who says it works? Who says it doesn't? Who doesn't have an opinion? Okay, you should fall into one of those categories, right? But some people didn't raise their hands. So, who doesn't care? You will. I promise you, you will care. Okay. So, who says it works and why it works? Yeah.
I have no idea why it works, but it seems like it works.
It seems like works.
Yeah, because like we said this LED K is associated with
Yeah.
key and LED button is also associated with button.
You are right for the most part. But when did I say which key? Did I say which key and which LED? I just said, okay, when the key is on, turn on the LED, right? Which LED? Which key? We should do it in another file, so we can separate our concerns. Okay, why aren't we doing it in this file? Because you will write this, and maybe later you will implement it in another board that has some other keys. So we will be using this. When I said you will use just those two, add another one. You will use a user implementation constraint file. So, what?
We didn't define the key as a plural. We didn't select the bus function.
No.
So the program thinks that there is only one key.
Yeah.
So it should.
Which one? It's just one key, right? But which one?
Program thinks that every key is the same.
No. Program says, okay, you didn't. Let's compile it and see what happens before we go. Okay, for compiling our program, we will have several. Steps. Okay. So here. So my computer's acting up. So for just in case, I will stop the recording and start the recording again. So if I have had 3 blue screens today. I don't want to lose our recording, so I will stop it for. Okay, let's start. Let's start compiling our program before defining which key. So there are several steps. 3 major steps: synthesizing, implementing, and generating the program file. Each of these steps do several things. In synthesize, this gets compiled in a middle language. You all know about. I'm repeating. You all have had the Java experience. Is there anybody who haven't had programming experience? Java?
No Java.
No Java. But in Java, you will be compiling. I mean, the difference between Java and C++ is that in C++ you, or in any other compiled languages, you will be compiling your program straightly into the processor code. But in Java, you will have a middle language. You will compile it into the bit file, and then you have another step 2. Here too, we have the synthesize. We synthesize our program, but we don't talk about the device that we are implementing. So I think that the synthesize will work without specifying any ports. Let's see. Okay, synthesize works. Do you think it implements? Let's see. It shouldn't, right? Now it does.
What happens when we say synthesize?
When we say synthesize, it synthesizes the program. It says, okay, can I describe this program by the language of gates? Can we describe this program by the language of gates? Can this program be divided into gates? That's synthesizing. For example, you are saying, we will issue that point too. I will show you the gates. I think we just made it crazy. Okay, implemented. Maybe it compiles, but it cannot work on the device.
Should we always rerun all steps?
No. If you change something, yes.
You have clicked rerun all the times.
What? Yeah, it's a bad habit. If I didn't change into here, if I changed something in my program, I should do the synthesize again. But normally when we are doing this, we have changed something in our program. So yeah.
So can we also directly start with the end?
Directly start? Yeah, normally when you want to implement your program. It did. Very nice. But it won't work on this, and it does. Today is my day to be wrong. Okay. So, for example, we have our bit files, right? So we need to go into what was the name of tutorial 2019? And that's the bit file. What? Okay. It did compile to my bafflement, but it doesn't do anything. Okay. It doesn't do anything because we didn't tell it which key. Okay, so we need to specify which key. We will be doing this in a implementation constraint file. Okay, let's name it tutorial or name it main, because it goes to this. Okay. So you see extension of the file is different. This is a VHD file. This is a UCF file, user constraint file. So here we should say net. I think this stands for, I don't know, network, something like that. So the name of our port, which was key, right? This is not a case-sensitive language, so you can use uppercase or lowercase. So you say net key, you're telling the program to connect the key port to a port on your device. Okay. On each of these keys, you will see something. For example, P plus a number, P15, P16, P12. That's the address of this this end. So, for example, I want this LED, which is P6, to be lit with this switch, which is P5. So my switch is P5. Okay. Location. But I don't know what does net mean, network, something like that. So it should be LED key. The address of one of these buttons is P35.
Can you please make the writings bigger?
Of course, of course. Thank you for pointing it out. Is it good?
Yeah, it's good. Thank you. Are you recording this?
Yeah. Should I? Oh, because you came later.
Can you start?
Oh, yeah. Let's check. Yeah.
Does it record the screen as well?
It's just recording the screen. I'm recording me too, but you don't want to watch me, right? I'm just doing it for my. If you want, I can put it in the. Is it good? Is it good to have the instructor at the side of the? Yeah, because I'm making some series. I don't know. Should I put myself at the? Does it help? Okay. How many think it helps? Having the instructor versus the screen. Okay, how many think it doesn't help? Yeah, the rest of the people don't care. Okay. P6, P3. Okay. So I save it and I run it again. So you will see that the synthesized part didn't change, right? Because I didn't change anything in my program. So if I do rerun all, it synthesizes again. If I just say run, I think I should have run the implementing 2 before doing it. Let's see. No, it just does. Okay. Hope it works. Come on. There are many situations like this, which did I tell you that you will pull your hair? That's when you do it. Let's rerun it. Debot, keybot. P3, the key P6, key P5, yeah, but P35. Yeah, it works now. I mean, there will be so many situations that you did all the things right and implement it. It should work. It doesn't. The best thing to do in those situations is just to recompile your program. Or sometimes you need to delete that bit file. I mean, this is the coursework LEC 204 something tutorial 2019 main.bit. If you do things, your implementation doesn't change, just go and delete that bit file and then do the compilation again. So as you saw, it didn't work. You didn't see it doesn't work. I saw it didn't work. I recompiled the program. It now works. So here. Do you see it? Okay, I will. Hopefully you will be seeing this. Okay, so I will put the webcam there. So you will be putting up with my face throughout 1 hour, and then for some seconds you see this, and then again it's me. Nice. Okay, so let's go further. What if I want to combine these two together?
Yes.
Of course.
Are we also able to define the initial action? For example, when we compile when we run all these files, instances, and implement design.
Okay.
For example, let's start LEDs starts with lighting, or
Yeah, you can do that. You can do that.
doesn't matter. Is it important?
It's not important. In some cases it is. You need to start it. You do it. I'm not sure how you do it. I think you are saying here you should say something like this. The LED, not the key. I'm pretty sure it's like this. So let's run it, and meanwhile, okay, so let's go further. I want one of these LEDs to lit when ANDing these two keys, okay? So here I need to start a process. I'm not sure if for AND we need the process, but it's the best case to always have anything except a straight wiring in a process. So for if, switch, things like that, you will need a process. I'm not sure if for AND you will need a process. I'm too lazy to check that right now. Now let's check what you asked and then continue. Oh, it was 0, right? It wasn't 1. I should have put 1 here for this to be. Sorry guys, just let's check this before we go along. How much time do we have? Okay, we can. Okay, so it's the best practice to put everything in a process. You can name your process, but again, because so I want to say, okay, LED bot is bot and key. So this LED is lit whenever the key is on and button is pressed. Any question?
Why did you put parentheses?
I am used to do that, and in other languages you should always put parentheses in each logical operation that you do. In VHDL2 I think so. I'll tell you why. Let's just so it doesn't lit up that LED. Maybe that's again the same problem. It should. I mean, we started the LED by 1. It doesn't lit up. You know why?
It doesn't matter.
It matters. It matters. Okay, good question. Why, despite the fact that I initialized the LED key with 1, why, when I implement my program on it, the LED is not lit? Why?
We haven't pressed the button key.
But it's initialized to 1. Why?
Because after initializing, we just said that if we press the key, then
Exactly. Because after initialization, you're saying, okay, the value of the LED key is key. So it will lit up for a hundred of millions of a second. You won't see it. If we haven't had this, it would lit up. Okay. So let's compile our program. So, not in VHDL, I'm not sure for the VHDL, but for example in MATLAB, okay, you say but and key, and you have some and other and there, okay. So, for example, you say but and key and something else, or you're saying but no, this is not that situation. We will talk about it later, why we put parentheses. There are some situations that it matters, so it's best to say clearly what you mean. There are situations, but I'm not, I cannot recall it right now. Okay, it asked me if I wanted to save my file. I wanted to save my file. Come on, what happened? So this is a kind of an error. Can you read it? What's the error? We need to terminate each line with a semicolon. Is it here?
I think so.
It should be, right? Most of the errors that you will see are these kind of errors. And one other kind, you can solve it easily. No one can solve the other one, which is a design error. Normally you will be frustrated throughout that error. And unfortunately, that kind of error is related to your device. I mean, not that device is faulty. Your program is right, but it cannot be implemented on this device. So you should change it. For example, your clock ports coincides with some other port. It doesn't work on this device. So you will see that error. I wish you don't, but you will. So which one was it? Yeah. Let me show it to you first. Okay, you see the key is on. The key is off now. If I push the button, nothing happens because I ANDed those guys, right? The key is on now. The key is on now. I'm not sure if you can see it. Can you? No? Sorry, guys. If I push it, the key is on. If I push it, it says, okay, this and this, if both of them are on. Do you see it? Yeah, okay. So hopefully this gets it. I cannot see if the webcam gets it. Okay. So one other thing, and I didn't think that it would take 1 hour. So let's see our program in another light. So here in Synthesize, we have view RTL schematics. That's one of the most helpful tools when you're writing a program. And you should definitely always decide about your RTL schematics before writing a program. Okay, how many modules do you have? How many, what those modules do? We always choose this. Okay, this is our program, our module. Our module has 2 inputs and 2 outputs. If I double click on it, okay, the key is straightly connected to LED key. Okay, this is an AND gate. Has your lectures started yet?
Yes.
But you are doing some base conversion and stuff, right? You haven't learned about gates. You will learn in the next weeks. You will learn about gates. So this is an AND gate. So it says now you can see it visually. That's what Synthesize do. Who asked what Synthesize do? Synthesize does this. Translate your program in some gate language. RTL stands for register. Sorry, guys. Register transfer level, I think, or language. I think it's register transfer level. That's another level. These are registers. So, yeah. Okay. That's you can do that by yourself later.